Hello and welcome back to the channel Understanding Concepts of Physics. As you might have followed my video links, and we have been doing thermodynamics. And in thermodynamics we are on to a topic where we are going to discuss lots of different kinds of processes. So as of this video, today we are going to discuss a very small article called as Isochoric process. So let's begin to discuss regarding isochoric process. So what is an isochoric process? Isochoric process is a process in which the volume is kept constant. So if the volume of a system is constant, we call it as an isochoric process. So the definition is pretty simple. The process in which I made a mistake over here. It's not pressure, it's volume. So the process in which the volume is kept constant is called as an isochoric process. So let's see the technicalities. The technicalities is volume is constant. So if volume is constant, there is no change in the volume. So if there is no change in the volume, change is written as dV. So if there is no change in the volume, the change is 0. So that's why dV is 0. So volume is constant, that means dV is equal to 0. We have been doing this since so long that the work done in thermodynamics is written as PdV. So if you can see, the work done is equal to PdV. So because dV is equal to 0, anything into 0 would go to 0. So dW is 0. So basically I can say work done in isochoric process is 0. Then if we apply the first law of thermodynamics, that is dq is equal to du plus dw. Now if you know that dw is 0, you can easily say that dq is equal to du. So that's what I have written over here. So these are the technicalities behind the isochoric process. Then let's derive some equations. You can see, we know that from the first law of thermodynamics, dq is equal to du plus dw. Du is the internal energy change, dw is the work done, q is the amount of energy. Because this is 0, because dw is 0, because this is happening because dw is 0. Maybe I'll change the color. Because dw is equal to 0, you get what is dq is equal to du. Now also in a few of the other topics we have discussed CV, that is molar specific heat at a constant volume. Molar specific heat at a constant volume is equal to du upon ndt. So if I take this n and dt on the other side, what I get is du remains alone, so that is du equal to n dt goes on the other side, so you get n cv dt. So this is one of the equations which is useful in a lot of numericals. So what I got is du is n cv dt, and that is also equal to the change in amount of energy. So I can write as n cv dt is equal to du, that is the change in internal energy. Now let's come back to the PV diagram. PV diagram is also called as an indicator diagram. And indicator diagram can be represented with pressure on the y-axis and volume on the x-axis. A is my initial state, so this is my initial state, and this is my B is my final state. So something is going from initial to final state and without changing volume. So the volume is not changing irrespective of what pressure is. So pressure is going from initial to pressure final, but the volume remains whatever it is. So this is the diagram for the PV diagram for isochoric process. Also you should be knowing that below the line the area is 0, and the area under PV graph gives us work done. Because there is no area under this line, we can say the work done is 0. So that is also one of the ways we can arrive to that part. And lastly, isochoric process is a process which is sometimes also called as an isometric process. So everything about isochoric process has been discussed. This is a very small article, so I have to wind up today with a very short video. Thank you so much for watching. In case if you are still with me, subscribe the channel if you haven't done so, and keep following and keep watching the other videos which might help you in your studies and exams coming forth. Thank you so much. Bye.